A solid right circular cone of height 27 centimeters is cut into pieces along a plane parallel to its base at a height of 18 centimeters from the base. If the difference in volume of the two pieces is 225 cc, the volume in cc of the original cone is 243, 232, 256 or 264. We are going to solve this question by two methods, so watch the video till the end to understand both the methods. Now let's see the properties which we are going to use to solve this question. If h is the height of the complete cone from which the frustum is cut, then from similar triangles we can write the following relationship. R upon capital R is equal to capital H minus h upon capital H. Now substituting the values in our question, we get R upon capital R is equal to 27 minus 18 upon 27, which can be simplified to 9 by 27. From this, we can get the relationship between small r and capital R. We get capital R is equal to 3r. Now let's keep this aside and move on to the next part. Now, after cutting the cone in two parts, we get one small cone and the other part is known as a cone frustum. The formula for volume of cone frustum is 1/3 pi h into bracket capital R square plus capital and small r multiplication plus small r square, where r is the top radius, capital R is the radius of the base, and h is the height of the frustum. Now, in this question, we are finally asked the volume of the original cone. For that, the formula will be 1/3 pi r square h. Now, we know the relationship between capital R and small r. So, we will convert the required equation in terms of small r. We can also substitute the value of the height of the original cone, which is 27 centimeters. So, now we get 1/3 pi into 3r square, which comes out to be 9r square into 27. Hence, our required final answer will be 81 pi r square. Now, the figure would be something like this for the given description. The total height is 27 and the big cone is cut into two parts at a height of 18 centimeters from the base. Now, as we have seen the formulas in the previous slide for volume of frustum, we will just substitute the values over here. So, volume of cone frustum is 1/3 pi into 18 into bracket 9r square plus 3r square plus r square. Solving it, we get 78 pi r square. Volume of the new small cone comes out to be 1/3 pi r square into 9, which comes out to be 3 pi r square. Now, it is given that the difference between the two figures is 225 cc. From this, we get the difference as 75 pi r square, from which we get the value of pi r square as 3. Now, it is given that the required volume of original cone is 81 pi r square. So, we get it as 81 into 3 as 243. Now, we have already found out the relationship between capital R and small r. So, we will keep it as it is. Now, we will find the ratio between the volume of the new small cone and the volume of original cone. Now, we know the formula of volume of cone. It is nothing but 1/3 pi r square h. So, we will just substitute the required values over here. The height for the small cone is 9, height for the big cone, original cone is 27. Now we know the relationship between r and small r. We will just substitute that and we will get the ratio of volume of the new small cone to volume of original cone as 1 is to 27. Now we can assume it as 1x and 27x. Now the frustum is nothing but original cone minus the small cone. So we can assume that the volume of cone frustum is 26x. Now the volume of small cone we have assumed it as x and volume of cone frustum as 26x. So the difference between them becomes 25x. But it is given to us as it is 225 cc. From this we can get the value of x, which comes out to be 9. Now the volume of original cone we have assumed it as 27x. Substituting the value of x, we get it as 27 into 9, that is 243. Thank you for watching this video. If you like it, please do share it with your friends and family. And also subscribe to our YouTube channel.